We're going to start this puppy up. Clear, prop.
And welcome back to Tip of the Week, Building Your Affordaplane. In this part, we're going to start dealing with our square tubes. This is the material that's going to make up our fuselage. Some of it is 2 by 2 inch by 1/8 inch thick, same thickness as our gussets. And the material is the 6061 T6 aluminum, just like our gussets. Basically, I used about 20 feet of the 2 by 2 inch, a bit less than that, if I recall. And then we are going to work with 2 by 1 inch. Same material, just the dimension is 2 inch by 1 inch. And used about 20 feet of that. We're also going to see how to cut it, because we have a number of places where the tubes come together and they need an angle cut. That's going to be relatively easy to do. And we're simply going to use the pattern that we created in the last part to lay out the lengths and angles for each of the tubes. Basically, they'll just be laying on the table in their proper location, and later we'll then tie them together with the gussets. Now again, in this presentation, we're building the Ultralight version. And you can tell that version right away because the tail section is made up of the 2 by 1 tubing, whereas the front section up near the engine is made up of the 2 by 2 section. And the reason this is done is to save weight. Now, the reason we're building the Ultralight version is because if you build the larger or heavier, it's not larger, but the stronger, heavier version, then it's no longer an ultralight. It is now an airplane, a light sport aircraft, which requires it to be inspected by the FAA, and you need a license in order to fly it legally. So we're trying to build the ultralight version here. And do notice in your plans there are some differences between the two. The major one being the 1 by 2 tubing for the tail, because that in fact saves about 5 pounds from the aircraft. And it may not sound like much, but later on when you're trying to get the weight down, 5 pounds is a lot of weight to try and make go away after the plane is all done and finished. The heavier version uses 2 by 2 tubing throughout the entire fuselage structure, not the 1 by 2 like we're using here. For those of you interested in seeing how much aluminum tubing is needed for this project, I just received my orders this week for 95% of all of the tubing necessary to build the aircraft. There's a lot of 10-foot and 12-foot tubes and some angles of all different sizes. I simply used the material list inside the plans to order this, and this is actually from 2 different vendors, and the approximate price was roughly around $3,500 of tubing. So let's get started. Let's start out with a simple tube, and by simple I mean it's short and the ends are straight. So in that case, we simply need to take a measurement, an accurate measurement, from one side to the other. And we're going to note the dimension and then transfer that to our tube. We'll transfer the measurement and then locate where you want the cut, let's say right there. And then it's important to use a square so that you get a nice straight line. and then go back and confirm your measurement with the paper. So measure twice or 3 times and cut just once. Now let's take this over to the saw and see what we can do. There are a number of options for cutting the 2-inch square aluminum tubing. I'm using a miter chop saw made for cutting wood, and it seemed to do a pretty nice job. Notice I have clamped the material down on the right side and wearing safety glasses because there's a lot of chips that go flying. But it certainly made some very nice cuts, nice and square. Okay. Another option is the miter saw with an abrasive cutoff wheel on it instead of the teeth. The one difference I noticed between the two types of blades is that the wood blade that I used cut in about 20 seconds to get through the 2x2, whereas the abrasive wheel took closer to a minute. But time is not that big of an issue, I suppose. And regardless of how you cut it, you need to sand and dress the edges to get all the burrs off. And then your tube will be ready for use. And then we check out how well we did. And that looks nice. I can see my line all the way around it. So now it's time to move on to a tube that has an angle on it. Let's increase our complexity. Let's create the tube on the very bottom of our fuselage. Notice that it is straight on this left end, and as we move to the right, we're going to have an angle. So we need to measure and mark this tube for the angle at the right side. Now there are a number of ways to do this, but I will pick one and we'll see how it works out. I'm going to assume that we're going to start with a new full-length tube here, and we're going to cut this angle at the end, and then we will cut the left side to the proper length because that's a straight cut. So really what I want to do is find this angle, and easiest way to do that is use a tool like this. This allows us to duplicate by simply moving the lever until it matches up. So I'm matching up this line and this line here to the best of my ability. Remember, we're not building the space shuttle, but obviously we can be as accurate as we can in the process. And there, I have this lined up pretty much just like that. Now, if I read this, and it may be a little hard to read there, but it basically says 16 degrees off of the 90-degree turn. Now, I really don't even need to read that because what I'm really going to do is mark my tube, regardless of what the angle number says. I'm simply going to mark my tube with that angle so that when I go to cut it, there is no confusion and no mistakes. Okay, here's a fresh tube. We're going to cut off this end at the angle and then worry about the left side later. My protractor has the angle that we set up using the paper. I'm going to purposely waste some space on this side so that it has a nice surface to be steadied by the saw when we go to cut it. So I'm simply going to draw this line. And now this angle matches the angle down here. So the next step is to properly set up our saw to cut this angle. And then we only have one more cut at the other end when we're done. That 16 degrees we got off our protractor can help us set up the angle on our saw, get us in the right ballpark, but we're going to want to carefully check the blade to make sure it hits our line at the correct angle. Every saw is different, but I find it somewhat difficult to tell if I have the proper angle exactly. So I used a small piece of metal, put it against the blade, and so as that sits across the top of the tube, I can tell whether I have the angle exactly on or whether I need to adjust it. So I will go ahead and cut this. Notice I have it clamped down. And I have my safety glasses on because there's quite a few chips that go flying. And we can go ahead and cut this. And that looks pretty good. So our next step is to go to the left side, mark it for a straight cut. And that would be right here. Note that you don't even have to use your tape measure. By lying the tube down with the end at the proper location, the one we just cut, you can simply carefully mark where the tube should end and cut it there. It's a square tube, so you can make the cut on any of the four sides and it'll come out just fine. Now let's tackle this tube here. This is the one at the front. We have an angle here and we have an angle over here. And guess what? Those angles are the same because this is 90 degrees to this component here. So we don't need to reset the saw after we get our first angle proper on one end. We can then take and mark and use the same cut. You may have to flip the tube around to get the angle at the other side. So let's try that. Of course, I'll be using the protractor. And before I make my second cut over here, I am going to measure it just to make sure I have it positioned properly. And then transfer that. And then we have an easy one on top because this is a straight piece on both ends. And then one more small one that is easy and straight right here. Now this cut may be one of your most challenging, only because it is very large in degrees. I measured about 53 degrees by using my protractor, and the issue is when you transfer this, does your miter saw go beyond 45? Seems to be kind of a common 45 to 50 in that way. So this is a little beyond some miter saws. If that be the case, you can use your bandsaw. You just want to take it slow because you're cutting through a couple of walls on either side, and that takes some time. But I'm going to go ahead and make this angle. I used a bandsaw and just went nice and slowly. And we simply need to finish the rest of the tubes using the same technique. We're down at the bottom where we transition to the 1x2, 1 inch across and 2 inches tall. And so we have an angle for this one here. So we'll use our protractor and get the angle across here. And then of course the 1x2, and I'll draw it here. Again, I'm leaving a little bit so that on the saw it has the ability to stabilize it. And that will fit nicely right here then to the saw. All right. Now we need to go to the other end and take care of that angle. And then basically, with everything in line, we just need to use that as our angle right there. And that should be our final cut. And here is our completed project at this step in the game. All of the tubes are cut and in their proper location. You can even experiment with placing a gusset over one of the joints to see how they fit. This small gap is the way it's supposed to be. About in there. And just a review of what the final outcome should look like. And remember, we're building the Ultralight version, part 103, so we need to use the 1x2 tubing for the rear tail. And we'll go around the top of the table. And here's the top section. And that concludes this part of building your Affordaplane. In our next part, we're going to add the gussets we made previously onto the metal tubes to tie the whole structure together. And that'll be a big deal because now we're going to end up with something that more resembles a fuselage than just a collection of tubes on a table. So, back to building, everyone.